Here is my video for the chapter 13 homework. So let's get into it. For number one, I started out using the conservation of energy equation. There was no initial potential energy and no final kinetic energy, so I was able to rule both of those out. Plugging in my variables for, plugging what I know for initial kinetic energy and final potential energy. I was able to use this equation to obtain my answer here. This D is supposed to be the same as a Y right here. Number two, I use this equation. I cannot remember if there's a name for it off the top of my head, but basically I have my initial kinetic energy plus work is equal to my final kinetic energy. So here I have my initial, again, I'm plugging in variables. First force, second force, that's my potential energy. And my final kinetic energy. And I was able to use this equation for both parts of the answer. I just kind of plugged different numbers in. I didn't show the other part on the paper just because I was plugging in different numbers, so I didn't think it was that big a deal. Number three, I started out with the kinetic energy plus work is equal to final kinetic energy. And again, I was able to solve this equation for x and obtain my answer. And then farther, and that's for the part one, farther down, where it's asking for the force and the different couplings. I kind of broke it up into, I have car A labeled up here. This is car B down here. I didn't label it. I probably should have, but yeah, this is pretty much everything that I did to find out. This FAB, that is the force on the coupling between car A and car B. This FBC is the force on the coupling between car B and car C. So yeah, I pretty much use this work, or this kinetic energy plus work equals final kinetic energy equation. There was no kinetic energy, no final kinetic energy because it wasn't moving. So yeah, that's how I did that equation, or that problem. Number four, again, kind of the same thing. It's kind of what I've been using for most of A, is this initial kinetic energy plus work is equal to final kinetic energy. I use that equation to simplify everything, and then I solve for whatever I need to know. So yeah, that's kind of how I did this problem. Number five, this one was kind of confusing to me. I understand how I guess I should say I get how to obtain the answer. I just would not have thought of it. I don't know. So yeah, I don't really entirely understand this. I do understand it. I just would not have thought of it. I guess I'd say that. Number six. Okay, yeah. So this one was dealing. So yeah, I had conservative forces up here. That was to help me understand exactly what kind of equations I'm using. So yeah, here I have initial kinetic energy plus initial potential is equal to final kinetic energy plus final potential. Down here I broke it up a little bit more. I have just initial kinetic energy plus elastic potential energy plus gravitational potential energy, and then the same thing for final on both of those. And then, yeah, using this equation, I was able to plug in different variables, solve for different things, and I got my answers up here. Number seven, I did, very similar thing. I plugged in all my knowns. Again, use this equation, plugged in all my knowns, plugged in all the variables that I know, and I was able to solve for my answer here. Number eight, I used, so this was when 13B started. Number eight, I used, it's not super obvious right here, but I used the impulse equation. So I have my initial momentum minus my my forces with respect to time, and then my final momentum. I was able to use that to solve for force and the amount of time that it took for the truck to stop. Number nine, so again, this was, I used impulse, the impulse equation on this one. There was no initial momentum. I have my forces here with respect to time, you can see, and my final momentum. Yeah, I was able to use this equation to solve for both my time and the force right here. Number 10, yeah, this one was kind of a doozy. Kind of the same thing with, what did I say number that was? Yeah, same thing with number 5. I don't know. I didn't entirely understand this one. Again, makes sense how you get to the answers. It was just kind of hard for me to grasp, so I don't really feel fully capable of explaining how to get there. But I did get my answers, and like I said before, it makes sense how you get there. It just kind of felt pretty roundabout to me. So yeah, that's 10. Number 11, there was a lot of, I only did A and B, C and D, I just haven't had time to do that. But for A and B, I don't know if there's a name for this equation, but I used this equation right here. So final velocity of B minus final velocity of A is equal to E times initial velocity of A minus initial velocity of B. There was a lot of just manipulating of that equation going on to obtain my answers. As you can see here, there's just kind of a lot going on. And number 12, so I was able to use, so I have here my initial momentum is equal to my final momentum. So I was able to use that equation to solve for this part A up here. And, I was able to use that along with conservation of energy. And then I was able to use this equation I used this equation along with that to solve for A. I use this equation down here. My initial kinetic energy plus work is equal to final kinetic energy to solve for part B.